Okay, so in this video, we're going to look at what is known as the equation of motion. And what happens is, because motion happens in real life, we can describe that motion using this equation of motion. So just imagine that you're riding a skateboard in a straight line at a constant velocity. And what we say is that t equals 0, your position will be known as the initial position. Okay, and so the initial position is often referred to as xi. Okay, but on the AP test, we call it XO, right? So remember, anything with a subscript 0 is the initial position, or initial. The equation is actually solving for the final position, right? And so you can just call it XF, or on the AP test, they call it X. And so the equation of motion goes as so forth is XF equals XI. So it's your final position equals your initial position plus the initial velocity times time. Now what happens is, because we're looking at constant velocity, this equation is simply the equation of a PT graph, or position time graph, from the previous lesson. So here is an example. A skateboarder with an initial position of 1.5 meters moves with a constant velocity at 3 meters per second. What position time equation models the motion of the skateboarder, and what is the position of the skateboarder at 2.5 seconds, and then how long does it take the skateboarder to get to 15 meters? Okay, so for part A, all we're going to do is rewrite the equation, right? And so I start with my XF equals XI plus VIT equation. Now I need to figure out what are the various what are the various variables. So this right here tells me an initial position of 1.5 meters. So that's going to go where XI is. Then it tells me a constant velocity of 3 meters per second. Okay, so that means when the skateboarder jumps on it, they're going 3 meters per second throughout the entire process. And so all I have to do is, this equation is solve for X or XF. So now I just plug in my numbers, 1.5 meters plus 3.0 meters per second times time. So that's my answer to part A. So that is what models this motion of the skateboarder. Now for part B, it's very simple. What is the position of the skateboarder at 2.5 seconds? So for part B, we have our equation that models our motion. Now I'm going to drop the units just to make it less confusing. They tell me I'm looking for it at 2.5 seconds. So all I'm going to do is plug in 2.5 for my t. And now that becomes my answer. So it's going to be on my calculator. Sorry. So I'm going to do 1.5 plus 3 times 2.5. And that's going to give me an answer of 9 meters. Right? So after 2 seconds, and the way you can think of it, this is like x of 2 is equal to 9 meters. Or sorry, 2.5, not 2, but x of 2.5. Okay, part C. How long does it take the skateboarder to get to 15 meters? So this is going to require a little bit of algebra. So it's going to say 15 equals 1.5 plus 3 times t. Okay, so again, this is the model of my motion. Now the difference was in part B, or we were given the time. Now we're solving for the time by giving the final position. So my first step is going to be subtract 1.5 over. So it's going to be 13.5 equals 3t. And then the last step is going to be to divide by 3. I'm going to do 13.5 divided by 3. And it's going to tell me it takes 4.5 seconds to get to 15 meters. So the equation of motion, again, just kind of highlight, is this piece right here, right? This xf equals xi plus vit. We are going to actually expand that when we ultimately do talk about what are known as the constant acceleration kinematics equations. So this equation is going to become a little bit bigger by adding in one component past it. But the next video, we're going. All right, so at this point, okay, our motion, and I apologize for saying in the next video because I forgot about this slide, but at this point, our motion is going to undergo a constant velocity, okay, which means right now our velocity does not change, right? And so you could see that it does represent a y equals b plus mx format. Now, I know in math class, you write it like this, right? Y equals mx plus b. What we say is physics writes math backwards. Okay. So some of the problems encountered, you'll have two objects traveling, right? And you'll have to determine how long it takes them to meet there. So what you just simply do is, and you can see the step here, write both motions of, the equation of motion for both of them, and then set them equal to each other. This is just simple systems of equations from math class. So you got all those techniques that you learned in Algebra 2 to solve these. Okay, so here we go. We got a friend. You and your friend are going to walk. You're going on vacation to Hawaii. Your friend is well ahead of you, seems sure to get to the gate first. Just when you spot a moving walkway going your way, right? At the moment you step on the walkway, your friend is 7.8 meters ahead of you and walking with a speed of 2.3 meters per second. Your speed on the walkway is 4.20 meters per second. How long does it take for you to catch up to your friend, and how far down the moving walkway do you meet up with your friend? Okay, so write the equations. So the friend, right, their position will be given by 7.8. So we're saying that you're the origin, right? So they're 7.8 meters ahead of you, and they're going at a speed of 2.30 meters per second. You, right, your initial position is 0, and the walkway is going to allow you to travel at 4.20 meters per second. And so what we're looking for is, right, when do these two equal each other? And so we're going to 7.8 plus 2.30 t equals 4.20 t. So I'm going to get my t's to both sides, to one side. This is going to be 7.8 equals 1.9 t. Right? And then my last step to solve for my t is to just divide by 1.9. So 7.8 divided by 1.9, it's going to take us 4.1 seconds to meet up with them. Okay, now to do the rest of the problem, all I have to do is take this 4.1, plug it in to any of the two equations, and that will give me where we meet. So we're just going to do 4.2 times 4.1, and it's going to give me a meeting point of 17.2 meters down the way. Now, you can also solve this using your graphs, right? So graph this, and then you find the point of intersection. Okay, so that's it for equation of motion. Look forward to